that's what ordinal means. Ordinal means it's in an order. So, something like ordinal would be something like, well, temperature. Oh, I guess temperature could be interval as well. That's tricky. Ordinal might be things like salary scales, because they're assuming that those salary scales have fixed bands between them. So, something like 10,000, 20,000, 30,000, 40,000, 50,000, or something like the movie ratings from 1 to 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are ordinal variables. Interval variables would be things like temperature, things like age, things like exam scores, all these type of things. And so is there a correlation between one type of variable and a different type of, so an independent interval or ordinal variable? Again, it has to be a numerical value. You can only ever do correlations when both of those variables are numerical. Yeah. They have to be either interval or ordinal. You cannot do correlations on categorical data, which is nominal data. So you can't do correlations on things like gender. You can't do correlations on things like postcodes or towns or job title or employment status. These things are unsuitable for correlations, and you need to look to a different type of research question if you're interested in those type of data. Okay, so is there a correlation between one type of variable and a different type of variable? Yeah, that's how you ask that question. The second question, a comparisons of means or a comparison of medians. And the way you're going to ask this is there a difference in the mean, or is there a difference in the median of, again, it has to be an interval or ordinal type of variable. So again, it has to be numerical, between independent nominal variable and another independent nominal variable. So nominal here means it's a category, it is a noun, it is the name of something. So an example here would be, so I should go back actually and give you an example for a correlation. So a good example of a correlation here is there a correlation between exam scores and room temperature? Assuming that you have a data set that has collected both exam scores and room temperature across many different scenarios, you could say, okay, well, is there a correlation between the exam scores of students and the temperature in the room? Because those are both numerical values, you can do a correlation on those. Yeah. Comparisons of means. Is there a difference between, well, is there a difference in the mean of the salary, which is an interval, sorry, it's an it could be interval, it could be ordinal, but it's a numerical value, right? So is there a difference in the mean of the salary between males in the UK and females in the UK? Yeah, so we have our big set of data is just going to be the population of the UK, and we might have one column that gives us gender or biological sex, and we can say, okay, well, is there a difference in the mean of the salary, which is our dependent interval or ordinal variable, between the first subset, which is the males in the UK, and independent, our second nominal variable, which is the females in the UK. Yeah. Another example might be, is there a difference in the mean of, exam scores between, again, between males or females in the UK? I quite like that one. Or is there a difference in the mean of salaries between people who went to university and people who didn't go to university, assuming that your data set has that type of information in it. Yeah. So you might have a column that said that has a university status, or university education status or something, and it might say went to university or didn't go to university or something. Yeah. Your final one is going to be a comparison of proportions, and this is going to be so I said it in the last tutorial, this is always a tricky one. Yeah, I'll explain it to you, and then I'll explain why it can be interesting, but also why it can be tricky. So a comparison of proportions is you're basically looking at the distribution of data, or the distribution of count of information or data points in different categories. And you have to imagine that you're going to be looking at multiple categories. So you're going to be looking at nominal data for your dependent variable and also nominal data for your independent variable. And you're going to be comparing between them. Yeah. And a good example here is asking something like, is there a difference in proportion of employment status between males in the UK and females in the UK? And if you imagine a data set where you had employment status, where we had values such as unemployed, part-time employment, full-time employment, contractual employment, 0-hour contract. So those are all categories. Yeah, they're not numerical. They are categories of different types of employment status. Yeah, so we have 5 different types of employment status, and then we have the males and the females as another type of nominal data. So imagine if you were to write this in a table, you would have males and females in your rows, and then you would have all the different employment status in all of your columns, and then in each of them you would have counts. Yeah. So say I'm not going to give you numbers because that's going to be a lot of numbers to deal with. But that's the way to think about it. And so we have categories against categories. And what we have in each of those little boxes are the proportion of each of those categories for each of those males and females. So each of those different employment statuses for each of those males and females. And then we would do some sort of statistical analysis on that data to see if those results were statistically significant. So it can be interesting if you have a data set that is particularly nice and gives you a lot of categorical or nominal data. It can be really, really nice, and you can generate some really interesting research questions from it. But I've seen it go wrong quite a few times. And the reason it goes wrong is because people either do it incorrectly. They don't use nominal data. This can only work on nominal data. You can't use it on numerical data because it would be unsuitable. But also because it demands a different set of statistical tests and a different type of visualization. When you get to your data visualization aspect, you'll understand a little bit more about that. But like I said, it can be interesting, but it's also a little bit tricky, especially if you're not familiar with it. So most people will go to either the correlation or the comparison of means. But don't let that put you off comparison of proportions, because like I said, it can be really, really interesting to set those things up. So this is an example of a YAML file. So this is what your YAML file is going to look like, regardless of what type of research question you're doing, right? So whether you're doing a correlation, whether you're doing a comparison of proportions, or whether you're doing a difference in mean or difference in median, the structure for your YAML file is going to be exactly the same. Okay, so first you're going to put in your group name, and that's going to be your group letter with an underscore, and then the group, and then the group number. Yeah, it has to be exactly like it looks like in StudyNet, because this is going to match against the group number in StudyNet, so don't put a space here, don't forget the letter. It doesn't really matter if it's capitalized or not, but don't forget it needs to be A or B underscore group, whatever your group number is. Members, these are going to be the names of everybody that is in your group. I don't have to go into that too much. That is just all the group members that you have. The topic, now this is going to be the topic of your research question, okay? This is not going to be the topic of your data set. This is not going to be the topic of the type of question that you're asking. So your topic is not going to be something like correlation or comparison of proportions or research methods or team research and development. It's going to be whatever topic your research question is referring to. Yeah. In this particular example, the topic is absenteeism. It would probably be a little bit nicer to see a bit more information there, but it doesn't matter too much. Okay, so absenteeism. The research question here is, and it's really, really important that we follow this exact structure when we are doing our own research questions, because we don't need to deviate away from it. Like the framework and the examples and the templates that we give to you right now, if you can stick to them, you'll be absolutely fine. People and groups get themselves in trouble when they start trying to do other things, or they start adding words or changing things. Like I said, it is in your best interest to stick to something like this as closely as you can. The wording needs to be exactly the same, but obviously it would be different depending on what your variables are. So research question, this is a correlation question. So is there a correlation between your dependent variable and your independent variable? So this has been cut off, but the independent variable here is distance to work of employees or of an employee. Yeah. So is there a correlation between absenteeism and distance to work of an employee? You can't see it here, but there is a question mark at the end of this research question. We have to remember that in the English language, it is only a question if you have a question mark at the end. If you do not put a question mark at the end of this question, it's not going to be a question. It's going to be a statement. And there is a mark on your rubric. So when we mark your assignments, one of the questions that you get marked on is the research question a question? And if you fail to put a question mark in, you're not going to get the mark for that, obviously. Okay, so this group has identified that they're interested in a correlation between absenteeism and the distance to work with an employee. Now, you then have to specify what those two variables are and where they are in your data set. So we'll start with our independent variable, and remember our independent variable goes second. If we go back to the structure of our correlation. So is there a correlation between our dependent variable? So what is the thing that we are measuring? That is your dependent variable, and your independent variable. What is the thing that your dependent variable relies on, or that you think it relies on? Yeah. Okay. So your independent variable here is distance to work of an employee. And they've identified that in their data set, and then their dependent variable is the absenteeism, and they've made reference to the column that their data set that is in their data set that refers to absenteeism. Now, you'll see in their research question that they have used correct English. It's readable. It doesn't make reference to the columns in their data set, but their independent and their dependent variable declaration does. This is really, really important. What we don't want to see in your research question is column names. So we don't want to see, is there a correlation between absenteeism dot time dot in hours and distance dot from residence dot to work? Yeah, because that doesn't make sense. That's not a human readable format. It's not legible. It's not correct English. So we actually want the research question to be readable by a human, and we don't want any reference to the columns in your research question. Okay, but when it comes to declaring your dependent and your independent variables, I know now that what they call absenteeism, we can see in their data set as absenteeism.time.in hours, which is, I think, has been cut off here. And then distance to work of an employee, which they've called as distance from residence to work, and that is there. Yeah, so there is a subtle difference in how they have formulated their research question and what their data set actually refers to. Yeah, but it's really important to understand when we go back to data.world to understand what each of these data points refer to, because if we don't understand what each of these things are, we're not able to, properly formulate our research question, because we need to understand that absenteeism time in hours actually refers to absenteeism, and distance to work of an employee can be measured by distance from residence to work. Yeah. Okay, so that's our research question, our independent and our dependent variable. We then have to deal with our hypotheses, and we have in science, you submit two hypotheses. You submit your null hypothesis and your alternative hypothesis. Some of you may have come across this kind of concept before, but very briefly, in science, when you are undertaking research and when you have a research question, your default position is that you do not expect to see a difference between, you do not expect to see a difference between the variables that you are measuring or observing. Yeah. And the point of conducting research is to see if you can disprove or find evidence against your null hypothesis. Yeah, you don't, strictly speaking, you never accept an alternative hypothesis, but you always find evidence to reject the null hypothesis. That's the way that science works. Yeah, I understand that's a little bit tedious. We can go into the, the meta science of things a little bit more if we want to, but we don't need to worry about it too much for now. Formulating these research hypotheses is fairly straightforward. It is just about rewording your research question in one of two ways. Okay, so if we go back to our research question very explicitly asks, is there a correlation between this type of variable and this variable? Yeah. Your null hypothesis is always going to assume and be written to expect no correlation or no difference in means or no difference in proportions, whichever kind of research question you're going with. Okay, so we take this bit here, sort of where it asks, is there a correlation? And we flip it around to say there is no correlation between, and then the rest of it is exactly the same between your first variable and your second variable. This should not look anything different to your original research question. It should not have any other type of variables. It should not have any other type of wording apart from what we can see here. Yeah. If you have added any variables in your null hypotheses that aren't in your research question, something's gone wrong. Okay. So is there a correlation between this and this? Your null hypothesis is there is no correlation between this and this. Yeah, that's step one. Your alternative hypothesis is then even easier to formulate. It's your null hypothesis, but you just change this word. You go from saying there is no correlation between to there is a correlation between. Yeah. You don't need to write things like we expect to see no correlation or we think there is going to be a correlation. Don't write those things. Either be explicit and say there is no correlation or there is a correlation. Naman asks, why can't we use var with correlation? I don't understand the question. So maybe you can expand on that a little bit in the comments. Your dataset URL. So you're going to submit the URL exactly as you have it in your in your URL bar. So you're going to right click, copy this, paste it into your YAML file. And again, this has to be the same dataset that you submit that you are working with, that you have also checked against the prohibited list, and that you have also checked against your uniqueness list, and then you will paste it in there. Yeah, simple. Columns is just going to be a printout of the columns in your data set, and this is going to be from R. So here we're just going to read our data set with read.csv. They're all going to be CSV files. They're all going to be CSV files. So you will not need to do anything other than CSV, read.csv, and then you're going to do a printout of the column names. This D here is going to be whatever you have stored your data set as. How do we check with the prohibited list? I went through that at the beginning of this tutorial. You're going to get a prohibited list in your labs, which you're just going to have to check against. Atisham asks, do we need to use specific words? You'll have to use a naming convention for your group. You'll have to use a naming convention for your dataset URL, as we've talked about, but all of this will be manually checked. Yeah. So your naming convention has to be, as it is, A or B underscore whatever this is, your dataset URL exactly as you have it in here. And then the column readout is going to be the full column readout, and then your independent and dependent variables should look exactly the same as whatever columns you have referred to. Don't change that bit. So that's the naming convention that you need to stick to. Okay, yeah. Again, comparison of means is exactly the same. We have the group, we have the member list, we have the topic, we have the research question, the null, the alternative hypothesis, the dataset URL, the column readout, the column names readout. One thing that I had identified in the last tutorial is this group hadn't submitted their independent and dependent variable column names, as we can see here. So probably would have definitely would have lost some marks. Abdul Model asks, we have to write these on TextMate. Yeah, TextMate if you're on OS X, or Notepad++ if you are using Windows. I guess, yeah, whatever text editor you have decided on, which you probably would have decided on by now. Okay, so comparison of means goes exactly the same way as comparisons or correlation. Okay, we have, is there a difference in the mean time spent in Chapel Hill Police Department between male and female officers, regardless of their rank and position? I would personally get rid of this. So it would say, is there a difference in the mean time spent in Chapel Hill Police Department between male and female officers? So we have, is there a difference in the mean time spent? Our null is, there is no difference in the mean time spent. And our alternative is, there is a difference. So remember, the setup is exactly the same. Is there a correlation? There is no correlation. There is a correlation. The research question here, is there a difference in the meantime? There is no difference in the meantime. There is a difference in the meantime. Yeah, that structure needs to be exactly the same. Please do not deviate from that if you're doing any of these. You need to keep it that simple. Abdul Muiz asks, what is 147? These are just readouts from R Studio, or that just refer to the index of each of those columns. So officer ED number would be the first column. This would be the second. This would be the third. Age is the fourth, fifth, sixth, and then race is the seventh. So you don't have to worry about that too much. Yeah, that's just something that RStudio does. Comparisons of proportions, exactly the same. So group number, members, topic, research question. This group has identified their independent and dependent variable. The research question is there a difference in the proportion of NBA championship winners between teams that have the regular season MVP, so the most valuable player, and teams that do not have the MVP? They've identified what columns they're going to be using. So their dependent variable is the NBA champion, and that refers to the NBA championship winner. And we can see that here. And then the independent variable is the MVP.team, which refers to the team that the MVP came from in that regular season. Okay, so research question. Is there a difference in the proportion? Null hypothesis. There is no difference in the proportion. Alternative, there is a difference in the proportion. We need to emphasize that that's how simple we need to keep it. Please don't add any extra words in there apart from the changes to the variables in order to align with your research question. Please don't say things like, there is no significant difference, there is no, well, yeah, don't write things like there is no significant difference, there is no, or there is a strong correlation, or there is going to be a strong correlation, or there is going to be a weak difference. None of these things, please. Okay? You cannot assess strength of relationships, strength of differences in proportions, things like that at this stage. So please don't add them in. Mohammed Rafi asks, where can we verify whether specific data set has been used before or not? We're going to provide you with some more information on that. You'll have to submit it to a form that I don't know if it's up on StudyNet right now or will be up soon. But you will basically have to submit your data set to that, and then you will get some feedback on whether that exists as part of the current list or not. Yeah, but you'll get more information on that this week. Okay, so caveats. Avoid data that are already summarized. So if your data set has columns that say things like average salary or average run rate or average age or mean exam mark or mean temperature, you cannot further summarize that. You cannot average what has already been aggregated as an average. Yes, you're not allowed to use those columns. If you come across something like that, you would have to use something else. So maybe there is some raw data that's available, or maybe look to a different data set. Avoid questions that can be answered by other means like logic or physics. To put it another way, don't ask questions that cannot be answered with your data set directly. Yeah, if it requires any other information or any other information that isn't implicit in your data set, you're not going to be able to answer it. You're not going to be able to formulate a research question from it, and you're not going to be able to do the statistical analysis. So only use data that is in your data set. Don't try to convert nominal data into interval or ordinal data. We've seen this happen multiple times. And so just to give you an example, we've had situations where we've had education status. So education status might go from like secondary education, college education, postgraduate education, PhD, etc., etc. That's nominal data. Okay, we've had groups that have then converted that from, say 1, 2, 3, 4, 5, which actually doesn't mean anything, because what does a 5 refer to there? Does a 5 refer to the college education, or does a 5 refer to, secondary school education, or does the 5 refer to a PhD? Yeah, or similarly, what does a 1 refer to? You cannot make those conversions. And the reason people convert that is because they want to do a comparison of means a difference in proportions or a correlation on those data points, you cannot do that. You leave the data as it is. If it is categorical, if it is nominal, if it has names or nouns or objects associated with it, you need to leave them as they are. And you probably need to do either a difference in means or a difference in a comparison of proportions. You cannot do correlations on nominal data. Yeah. Follow the research question templates. I've said this a couple of times in this tutorial. Just stick to the templates that we have given you. Stick to the YAML file templates that we give you. Please don't try to change them. The wording is really, really important. Even if you think it's a subtle change, research questions are very, very tricky to get right. And we're giving you a lot of the information. We're trying to make it really easy for you. So please don't deviate from the information that we've given you. You will get marked on your spelling, grammar, and punctuation. So please make sure that's right. If we go back to our tutorial on Trello and all the different processes, remember one of those processes was reviewing. In that review stage, I would encourage you all to check this kind of thing. Yeah. So make sure that your questions and your research questions end with a question mark. Otherwise, you're going to lose marks for that. Your statements, so your null hypotheses, your alternative hypotheses, make sure that they have full stops, so periods at the end, because that's how you end a statement or a sentence. And write things like correlation. Don't write correlation or relation or relationship. Don't write things like a difference of averages or if you're going to write proportions, I've seen a difference in portions or a difference in the number of proportions. Like, these are not grammatically correct statements. Stick to the format that we've given you and you will be okay. Finally, we're going to give you all the opportunity to, if you like, to get some feedback before the deadline. And if you want to do that, the way to do that is to set up with your group, get your research questions set up, formulate your research question, formulate your alternative hypothesis, formulate your null hypothesis, identify these variables in your data set, and then you're going to create 3 slides. On the first slide, you're going to have your group name and the members in your group. That bit's fairly easy. On the second slide, you're going to have the dataset URL. You're going to have your independent and your dependent variables from your dataset, and that's going to be the column headers. And then on the third slide, you're going to have your research question, and then you're going to also present your null and your alternative hypothesis. Just 3 slides. We don't need any more than that. Please, you're not going to have that much time to present. If you do want to present, you're going to have less than 5 minutes. So we only want to see 3 clear slides with all that information. The way to do that is you're going to sign up on Canvas and for a presentation link. And those presentation links are going to be those presentation slots are going to be made available here. So you will see them, you will click on them, and you will just put your group number in, but you'll get more information on that very shortly. And then the idea is you turn up to the slot or the lab or the tutorial that you have signed up to, and you and the rest of your group present. Well, maybe one of you nominate one of them to present, but you and all of your group members would turn up to that slot. You would present, you would get some feedback by the tutors that are there, and you would go off and you would, see if you can take some of that feedback and work on your projects a little bit more, on your assignments, a little bit more before the deadline. It's a really good idea to sign up when the signups go up to get some feedback. We found that the groups who have done this in the past have gone on to get get much better marks than the groups that haven't. And there's no pressure, right? So remember, you're not going to get marked on these presentations, but it is an opportunity for you and your group to get some feedback before you submit and you actually get marked on your assignments. But this is really important. If you sign up and you fail to turn up, you will lose 5 marks from your research question deliverable. The reason for that is because we have a finite amount of slots. Yes, as Iman says, there's a limited amount of slots. We're going to make the slots available for everybody. So we're going to give people the opportunity to present. Every group is going to get the chance to present, but it's first come, first serve on which slots people choose to take. So if you sign up to a slot and you don't turn up, you have basically taken that 5 minutes away from a different group that might have presented, or not a group that has had to choose a different slot or a different day because that slot has been taken. Yeah, we will penalize for that because that is disrespectful to, well, first us as the module staff, but also the rest of your group, or rest of the people in this module who are also interested in presenting. So you will get penalized for that. Please make sure if you sign up that you do turn up. We'll make more information available for that soon. The questions like when could be the last day for choosing the slot, I'm not entirely sure, but like I said, all that information will be made available to you very, very, very soon, and you'll get all that information on Slack as usual. We have run out of time, but I'm hoping that was helpful for anybody for everybody, because everybody's going to be doing this assignment, but in helping you think about the type of data you might need, the type of data sets you might be looking at, the type of research questions that you might be interested in formulating. So my advice for you and your group now is to go out there, have a look on data.world, find some interesting data sets. Don't just look at one data set, maybe collect a few, explore them, and you will get some feel and some idea of what kind of research questions you can ask. We have a question about the quiz on the 4th of November. That is going to be on the reading. That information, Mohammed, is available on Canvas. So I would encourage anybody who has any questions about the quiz to look on the assignment briefs on Canvas, because that information is already made available to you, and you should already have started making some way into reading the required reading for that quiz anyway. Okay, we'll leave it there. Norman asks again, what is the last day for verifying the data sets? Again, that information will once I've got concrete dates and stuff, we'll make that available to you. But I'm just letting you know for now that is all coming very, very soon, potentially today. So just be aware. Yeah, we'll make all that information available to you very, very quickly. Okay, cool. Well, guys, thank you for your attention. We'll leave it there. If you want to attend another tutorial, that's entirely up to you. Otherwise, I'll see you at some point later this week. Thank you very much. See you guys later.
Thank you. Thank you very much.